Okay, so this chapter we're wrapping up today, and it's 11.9 about normal distributions. All right, so if you have anything left from yesterday, pass that forward, 11.8. If you have anything before that, put it in the purple box after instruction today. So you should have already worked the study guide through number 10, right? And that would catch you up with today. Today we're doing the last lesson. So on the study guide on your blue sheet, you'll be working 11 and 12, and then you'll be done. So don't forget that the study guide is part of your assignment every day also. So I ask you to find the mean of these numbers. Did anybody find it? What'd you get? And that's exactly what, oh, I shut down. My screen locked up last hour. So I had it marked from first hour, but because I lost all my files, I lost it. It was 24.4 is what they had also. So let me see if I can add it now. First hour had 24.4 and third hour has 24.4. Did anybody get anything different? Okay, remember for the mean, we also call that the average, or X bar is the same thing, right? So you're going to see it all of those ways. Today we're going to talk about discrete probability distributions. It has a finite number of possible events or values. The binomial probability distribution that we studied yesterday is also a discrete probability distribution. The events for a continuous probability distribution can be any value in an interval of real numbers. If the data set's large, the distribution of its discrete values approximates a continuous distribution. So what it means is when we look at things, even in the real world, for example, maybe the height of all the female population, you'll find that there's about an average height, and all the other heights will fall in this natural curve, this natural distribution. That's all they're saying. It's continuously distributed. So many common statistics, such as human height, weight, or blood pressure, gathered from samples in the natural world, tend to have a normal distribution about their mean. A normal distribution has data that vary randomly from the mean. The graph of a normal distribution is just a normal curve. So that's what we're going to be dealing with today. Here is a normal distribution. It is scrunched up a little. It's a little more stretched out, like, here, let me see if I can do those. It's a little more stretched out like that. Okay? So what it says is we have an average or a mean, and I ask you to take an average of those numbers today. Well, whatever the mean is, that goes in the center. And you would put this against a number line. For example, you said it's 24.4. I'll just put 24. And then if we had a standard deviation of 2, then we know that we're going to subtract 2 to get to 22. So there's one standard deviation to the left and one to the right would be adding 2. So 24, 26. And then to go 2 again, we're going to be at 28. And 2 more is at 30. And then, let's see, standard deviation back. So back to 2 standard deviations here would be 22 minus 2, which would be 20. And 20 minus 2 more is 18. So if this was a standard deviation of 2, we could say that 68% of the data is going to fall within one standard deviation. Do you see that? One that way, one that way. That's within one standard deviation. You have 68% of your data. Now this part holds true no matter what our number lines are. Okay? So within one standard deviation in a normal distribution, 68% of that falls within one standard deviation. Okay? And then within 2 standard deviations, we have Well, 13.5 and 13.5, that's 27 plus 68. So 27 plus 68, that's going to be 95% of the data is going to fall within 2 standard deviations. Do you see that? There's 2 and 2. That's 68% of your data. And then you're going to have 2.35 and 2. So 4.7. So 4.7, so it's going to be 99.7. 99.7% of your data falls within 3 standard deviations. And then there's that 0.3% that's unaccounted for. And we'll learn how to deal with that on the last problem. Okay? So when you look at this normal distribution, it's got a beautiful curve. It's nice and even. The height is right in the center. The highest point is right in the absolute dead center where the mean is. And it falls evenly on each side. If you get data that's skewed, it's going to change this distribution. Okay? For example, you might have an outlier. It can cause your data to be positively skewed or negatively skewed. So how do you remember which is which? Well, I just drew this silly little picture to help you. If this was a number line where the positive moves to the right and the negative moves to the left, well, I can stand my little person inside this little valley here on a positively skewed. That's on the positive side of the number line, right? If this was a number line. That's how I remember. Okay, whatever you want to use to remember, you don't have to use people. You might just be able to look at it and know, okay, that's a positive. It seems to be rising up and falling to the positive side. You can see it that way. This one's right dead in the center, so that's normally distributed. And then this one, it's we've got space over here. We've got a valley on the negative side that's negatively skewed. Okay? Any questions about that? All right, so look at your workbook, problem 1, and answer the first 3 questions. Are these positively skewed, negatively skewed, or normally distributed? So what's number 1? Normally. And what's number 2? Positive. And what's number 3? You're right. See how easy that is? Okay, let's back up to the first problem. Analyzing normally distributed data. The bar graph gives weights of a population of female brown bears. The red curve shows how the weights are normally distributed about the mean, 115 kilograms. So they're telling you right there, there's your mean. So that's the top of that center point, right? 115. Approximately what percent of female brown bears weigh between 100 and 129 kilograms? So let's look. Here it is. They said our mean is 115 kilograms. There it is. Now they put data and values to our curve. Do you see that? And they've gone ahead and marked out our chunks of data. Right? So we know that this one in the center is what? 68% of the data. And that's within 1 standard deviation here. There's your 2 standard deviations, and there's your 3rd. Right? So recognize that pattern in these things, whether we're using it like that or not. All right, so what did they ask us? Approximately what percent of female brown bears weigh between 100 and 129 kilograms? So here's the 100. So it starts right there. And the 129 is actually ending right there. So we're looking for all of this data in between here. See that? So what we need to do is look at what's over here on the right. There's our percent of bears, and they're in units of 5, 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So let's look at where this first one lays. When you bring it over, it's at about 23, 24. Let's call it 23. So there's 23% in this range. And in this first standard deviation range, we're at about 42. Do you see that? And then this third one is the same as the first one. So again, that's going to be about 23%. So now let's just add that up. So you're going to have 6, 8, and then 4 and 4, about 88% of the bears fall within this range. That's all there is to it. Let's see if yes, I matched with them. I think I used 24% last hour and we were off. We had 90. But, realize that it is an average. And just by the way that you read your chart, you might be off a point or two. So always look at all your answer choices on a test, your A's, B's, C's, and D's, before you choose the appropriate answer. Get the one that's closest to your value, because these are approximations, okay? Any questions on that first one? Okay. Let's look at number 4, 5, and 6 on your worksheet. It says the bar graph below displays the heights of students at high school. Use the graph to answer the following questions. And let's take a look here. It does look like a normal distribution, right? So we know the mean would be right there in the dead center, which I can't draw a straight line on this thing. And then it's going to go and out. Okay, so, actually I copied one right here, didn't I? So there it is. There's the one I copied from another page. So, there's your first deviation, the second, then the third, and then there's some extra stuff, right? So it says approximately what percent of students are between 61 and 67 inches tall? Okay, so 61 is right here, begins there, and 67 starts right there. So they want between 61 and 67, so we're just talking about this one and this one. So where do those fall? Where does the first range fall? At about 12. I agree. And how about the next one? 18 or 19? I'm going to use 18 just because I like even numbers. So 8 and 2 is 10. That gives us about 30 inches, or 30% are between 61 and 67 inches. So you can say about or approximately 30%. Any questions? Okay, work the next two, 5 and 6. So depending on how you read things, I got about 81. You might have had 82%. Both of them are acceptable. Remember, in a test, you would just choose the one closest to your answer. And then for number 6, about 33. And in my book, I had 32 when I worked it before. So 32, 33, somewhere. So tell me, what values did you use to get that? Okay, and it's because you did 35 and I did 33. See, the middle, let's see if I can do this. It's not quite at that middle. I'd say it's right underneath it. So that's why I used a little smaller. It was probably more like a 34. Okay, but it wasn't exactly halfway up, or it could be an optical illusion, but all of them are acceptable. I wouldn't count it wrong, and everybody's going to have, vary by 1 or 2, depending on how they read the charts. Okay? Any other questions? All right. Number 7 on your workbook assignment, it says your mother has a rose garden. Every day she sprays fertilizer on the roses in one section of the garden. Do you expect that the heights of the rose bushes in her garden are normally distributed? Explain why or why not. So, do you expect the heights are normally distributed? Why or why not? So it's yes or no, and then explain. So she's spraying on one side. Maybe she's spraying here, right? So what would happen? Would it make a normal distribution? What would happen?
It would make a negative, right?
It would make the data on, yeah, it would give us some outliers. By these guys that she's spraying, they would be unusually tall compared to the others. The others won't grow as fast as the others. So it would skew your data. All right. Any questions on that? All right. Let's move on to the second problem. Sketching a normal curve. Now we're going to learn about sketching these. And I showed you, I keep a little copy on each page. This is what we're talking about, this curve. And that's what I showed you at the beginning of class. So keep this in mind as we talk about these things. It says in zoology, for a population of male European eels, the mean body length and one positive and negative standard deviation is shown below. So they're giving us the mean body length and one standard positive and negative standard deviation. Okay, so let's see what that is. Okay, here's the mean body length. So x bar is equal to, and there it is, 15.7 inches. Whoop, and I can't write. Okay, and then they said a positive standard deviation is 18.5 inches. So, and then a negative standard deviation, one of them, is 12.9. So let's see what the difference between the mean and the first standard deviation is. So we're going to take 18.5 and subtract 15.7. And so that gives us 2.8 difference, right? So that was the mean. He's going to be up here. Right, whoops. Up here, the mean. That's going to be my 15.7. The first standard deviation is 18.5. So this difference right here is 2.8. Now let's look at the negative first standard deviation. It said that it was 12.9. So let's take that mean value and subtract 12.9 and see if it's also 2.8. It should. but we're going to verify it. So 15.7 minus 12.9. Also 2.8, which is what we expect. So let's look at this on our normal distribution chart. So there's the mean, and here's our first deviation, second deviations, and third deviations. So on the mean we know is 15.7, and we know each standard deviation is 2.8. So add it going this way, so you get 18.5, and subtract it going this way, 12.9, and that's what was given, right? These three things were given. The mean and the first positive and negative deviation. So from that we can calculate that the standard deviation is 2.8. So if we carry that on out, then to go to the second deviation, you're going to subtract 2.8 from that, and you're going to get 21.3. Subtract 2.8 from that, and you get add to the right, you're adding 21.3, add 2.8, you get 24.1. Going to the left, we subtract 2.8 to 10.1 and 7.3. So does everybody see how to get the numbers down below? Take your standard deviation and just carry it on out, because it said it's distributed evenly. So if it's 2.8 here, it's going to be 2.8 for each one. And you just take that normal picture of the curve that I keep showing here and fill this chart in. Just fill the numbers in below. Write your mean and then write your calculations for your deviations. Okay. Now, what are they going to ask us about this? They ask us, they didn't ask us anything, did they? So I guess we were supposed to just sketch the normal curve, and that's what we did. Okay, so you take that curve and just do those additions and subtractions of your deviation. Any questions on that? Okay, look at number 8. It says sketch a normal curve to represent each of the following normal distributions. It says the average weight of a tomato in a tomato garden is 10 ounces. So there's your mean right there. So let's draw our chart. So remember, it looks like this. So you want to draw this, maybe without all that terminology. But you want to draw that mean and then your first, second, and third deviations on each side. Now, what we're doing is we're going to fill in numbers down below. Okay, so we know right now that the very center point, the mean, is 10 ounces. 10. So pencil that in. Now, the standard deviation is 1.6 ounces. So now sketch a normal curve showing the tomato weights at 1, 2, and 3 standard deviations from the mean. So what you're going to do is you're going to take the 10. Whoops, I didn't mean to do that. We have 10. And we know the standard deviation is 1.6 ounces. So let's fill these out. So we're going to add 1.6. And that's going to give us 11.6. And again, add 1.6 to get the next value. And that's going to be, I just erased it, 13.2. And now let's get the third deviation. So add 1.6 again. And what are we going to get? 13.2 plus 1.6, 14.8. Okay, now do the left side, but you're going to have to subtract 1.6 each time. So 10 minus 1.6, well, 10 minus 1 is 9, and 9 minus 0.6 is 0.4, so it's 8.4. Now, subtract 1.6 again, and what do we get? 6.8 for the second, and how about for the third? Subtract 5.2. That's correct. See how easy that stuff is? Any questions on this? So once you get the mean and the standard deviation, you can calculate these values very easily. Okay, can you remove your, thank you. All right, let's look at the next question. Number 9 says the average score on a math test is 76. The standard deviation is 6.2. Sketch a normal curve showing the test scores at 1, 2, and 3 standard deviations from the mean. So again, you're going to do the exact same thing using this new data. 76 is the mean and 6.2 for your standard deviation. So write that out real quick.
76 is the mean?
The average score is 76, so that's your mean. And standard deviation is 6.2. When you finish, compare to mine up here. Okay, is everybody good? So the negative third deviation would be 57.4. Negative 2 deviation is 63.6. And the negative 1 is 69.8, bringing us to our mean of 76. And then our first positive distribution is 82.2. Second positive, 88.4. And the third positive is 94.6. Does anybody have any questions on those? Okay, good. So let's analyze this for a second. And I use this chart for a reason. If I ask you what percent of the scores fall between 69.8 and 82.2, it would give us this in the shaded region, right? So you would say, well, 34 plus 34, 68% of the test scores fall between 69.8 and 82.2. Do you see how to read those charts? And if you wanted to know how many fall between 88.4 and 63.6, then you would say, well, it's going to be 3.5 plus 3.5 plus 68, or 7 plus 68. So it'd be 75%. Right? Does everybody see how to use these charts? It basically brings us right to our next problem. So Here's a normal distribution chart with our values, our mean and our deviations on it. And notice that it just looks the same. The only thing that really changes is this number line at the bottom, right? It says the heights of adult American males are approximately normally distributed with the mean of 69.5 inches. Standard deviation is 2.5 inches. What percent of adult American males are between 67 inches and 74.5 inches tall? So let's look. Where's the 67? Right there. Where's 74.5? Right there. So it's all of this shaded area that falls between those. So let's get those percentages. So 34 plus 34 plus 13.5. Right? So 34% plus 34% plus 0.135 is going to equal 0.815, or about 82% of American males are between 67 inches and 74.5 inches. All right? Any questions on that? Pretty easy stuff. All right, so let's look at the last problem before we do any more homework, because this one's a little different. It says, in a group of 2,000 adult American males, about how many would you expect to be taller than 6 foot, or 72 inches? So this one's a little different, because remember when I told you when we look at that chart that it does not, we're missing 0.3% on the ends. So you have to be real careful when you're talking about just how many over a certain point. You can't just add this and this, because we don't know what portion is the 0.3% all on this side. Is maybe 1% here and 5% over here? Or, excuse me, the rest of it over there. All right. So we have to be real careful about this. So let's take a look at what we have. How many are higher than 72 inches? So what we have to do, because of that 3% on each end, and we don't know where it falls, on the right or the left, or is it even on right and left? Probably not. So what we have to do is realize, okay, well, we do know from the mean to each end is 50%. The mean divides everything into 50%, right? So if we're trying to get everybody greater than 72, then what we have to do is take our 50% and we have to subtract from that, because we've got this side. We're going to subtract from that this 34. Okay? And when we do that, what do we get? 0.16, because these were percents, sorry. 16%. Okay, so how many males did they tell us again? So we know about 16% of the males are over 72 inches. They said in a group of 2,000. So 16% of 2,000. And remember, when we say of, it means multiply. So 16% of, multiply, 2,000 is our answer. So when you multiply that, you're going to get 320. So 320 out of the 2,000 count, we're going to have 320 of those over 6 feet tall, over 72 inches. Okay? So when we go talk about things just greater than, that includes our edges, you have to take the whole 50% and pull out what you don't, what's not accounted for. Okay? Any questions on that? All right, let's look at the last two problems and then we'll be done. We're going to finish and turn this in. A local bakery makes chocolate chip cookies. The number of chocolate chips in the cookies is approximately normally distributed with a mean of 11.4, so there's your mean, and a standard deviation of 1.3. What percent of the cookies have between 8.8 and 14 chocolate chips? So we have to make our chart first. So the mean's 11.4 and our standard deviation is 1.3. So again, I'm going to pull this guy out. And actually, let me make it longer. There we go. All right, so mean is 11.4. Now fill in all your standard deviations. Subtract 1.3 from or add 1.3 on this side and subtract 1.3 on this side. And keep it going. So fill out the rest. 12.7. So you should have your number line done with the mean being 11.4. Double check your answers against this. So moving to the right, you should have 12.7, 14, and 15.3. And moving to the left, 10.1, 8.8, and 7.5. So now they ask us, what percent of the cookies have between 8.8 and 14 chocolate chips? So here's your 8.8 is there, and 14 is, whoa, I didn't mean to grab that. Sorry, that's going to go crazy on the video. All right, and there's your 14. So what percent is that? Well, it's between 8.8 and 14, you've got 13.5, 34, 34, and 13.5. What? 95%? Let's see. Let's add those up. So we know 34 and 34 is 68. And 13.5 and 13.5, well, 13 and 13 is 26. Plus 2 halves is 27. And when you add those, that is definitely 95%. So your answer is 95%. Nice and easy, isn't it? Any questions on that one? Do we have to use this chart? Well, it doesn't have to be labeled and have all the percentages in there, but yeah, that's the chart that you're using over and over and over. And this is what all of those lines mean. That's your mean. Here's your first positive standard deviation and your first negative standard deviation. Your second second, and your third, your third. That has to be on all your charts. And this is the shape of the curve. So do we have to use this particular one? No, but it should look almost identical to that. Yes, these don't change. That's the beauty of what we're doing here. Are these percentages don't change. All we're doing is adding the data and the numbers at the bottom, and then adding values to the answers. Okay? So it will always look like this, but what you're doing is adding the stuff here, the numbers, and then you do the calculations. Okay. So number 11, I covered up, I think. So you'll turn these in tomorrow if you're leaving now. Don't do 12. So spend the rest of the class period, the next 3 minutes, on 11. Oh, I erased everything. It says the bakery described in exercise 10 sold 200 chocolate chip cookies. How many of the cookies had less than 8.8 chocolate chips? Oh, I hate that I erased it. Well, it's the same chart. So let's see if I can get back to it. There it is. Nope, that's not it. No, not yet. There they are. Okay, so what was the question again?
Is the number 10 going to be the new?
What was, oh, here, I've got it right here. They sold 200 chocolate chip cookies. How many of the cookies had less than 8.8 chocolate chips? So you have to look at the 8.8. Here it is.
We're using the same
Uh-huh.
chart?
That's what it said. The bakery described in exercise 10, so the one we just worked, sold 200 chocolate chips. So chocolate chip cookies. How many of the cookies had less than 8.8 chocolate chips? So this is the one where we're going to have to take the 50%, and we know it's going to be all of this. So we're going to have to take 50 minus this, 34 plus 13.5. So 34 plus 13.5 is going to be 47.5. And we want to take that from 50. So 47.5, 48.5, 49.5. So it's 2.5. 2.5%. So that's 0.025. And you're going to have to multiply that times the number of cookies. And that's your answer. And that's everything, guys. Work the rest of your study guide, and we'll go over that tomorrow. Thank you, and that concludes our lesson.